nine 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 nine.
Well, hello. Welcome to week 9 of CS 3102. So, last week, what we did is we introduced this Turing machine model of computing. And this, we said, was sort of the final word in practical models of computing. So, this is sort of where we're going to stick for the remainder of the semester. So, last week, we gave we introduced the model of computing. This week, we're actually going to be exploring some of what Turing machine models cannot do. So you've probably already seen a lot of things that Turing machines can do because you've been through at this point multiple programming classes, and everything you've done in your programming classes are things that Turing machines can do. Now, what's going to be interesting is what things can't Turing machines do, how do we know they can't do those things, and why can't they do those things. So we're going to be living in that space for this week and into next week as well. So we're going to be talking about two functions this week that Turing machines are not going to be able to compute. The first one is this self-reject function, which which tells us whether or not a Turing machine, when thought of as a string, is going to reject itself as an input. That one is not going to be so practical, but we're going to be able to show that that is not computable. The second function we're going to be talking about this week that is not computable is this accepts function. So this accepts function says that if we have some sort of Turing machine and an input that we might want to give to that Turing machine, how is the Turing machine going to respond? So this is essentially this question of, am I able to look at a Turing machine and an input and figure out how exactly that Turing machine is going to answer? Now, the problem we're going to see with this accepts function is that if we were to just try it sort of by hand to work through the Turing machine running with that input, then we're going to run into this problem because there's going to be this possibility that Turing machines could end up in infinite loops and never actually stop running. So that procedure might not necessarily work. So we might want to say, is there some way we can analyze the machine itself and what it's going to do with that input to be able to answer this question of how is the Turing machine going to respond anyway without necessarily running it? And what we're going to see by the end of this week is that that is actually not going to be possible. That it is impossible in the general case to look at a machine and look at an input for that machine and answer definitively every single time how the machine is going to respond. So that's what we're going to be ending with at this week, and that's going to set us up for next week where we can have sort of a template for how we're going to be able to show additional problems are going to be not computable.